Hello Model 3 and welcome back to our science videos on Unit 2. Okay, today we will discuss some different branch of science, which is physics. Physics, of course, we have done the biology in the chemistry in the first unit. Today we will start with just one unit about physics. In this unit, we will discuss some important figures, some important topics in physics, which is electricity or electrical energy and radioactivity and the meaning of both of them. What is the meaning of electricity and how it is generated and how it can pass through different connections, and the radioactivity and the meaning of it, the origin of it. Okay, lesson 1. In lesson 1, we will discuss the physical property of electric current, the meaning of electric current and its physical property. In lesson 2, we will discuss something very important. It's called electric current and cells, electric cells, not cells in our human body. It's biology, of course, but we'll discuss some different cells. It's called electric cell, like the battery, of course. Lesson number 3. Radioactivity and the nuclear energy, and we will discuss what is the relation between radioactivity and nuclear energy and how the radioactivity is generated. Okay, let's start with lesson 1. Of course, in lesson 1, as I said before, it is about the physical properties of the electric currents. But before doing anything about that, before discussing anything, we should know something, or we should remember them. The changing of electricity. Of course, we got some property of electricity before, but we should know that you can see the effect of electricity when electric energy is changed into another form. Like the electric energy is changed into light energy in the electric lamp. Of course, the electric energy in the lamp changed into light energy. And the electric energy is changed into heat energy in the electric heater or iron. When you make your clothes handsome. Letter C. The electric energy is changed to mechanical energy in the electric motor. Okay, mechanical means kinetic, moving, something like that. Okay, letter D. The electric energy is changed to sound. Electric energy here is changed to sound in radio, cassette recorder, and telephones. Okay, like this electric bulb, iron, room heater, electric fuse. Okay, generation of electric current. How we can generate electric current? Electric current consider a wire of copper. The atom contains positively charged protons in the nucleus and negatively charged electrons. This is what we concern about. The negatively charged electrons inside the nucleus, this is what we will study. This is electric current. This is the cause that we name the electricity because it comes from the electrons. So negatively charged electrons revolve around the nucleus. Okay, the attraction force between the protons and electrons keep them together. Electrons in the last energy level are weakly attracted to the nucleus. Again, electrons in the last energy level are weakly attracted to the nucleus. Electrons in the last energy level can flow from an atom to another, can transfer from an atom to another. Some atoms can lose electrons and some others can gain electrons, as we know from chemistry, of course. But if the copper wire is connected in the closer circuit with a battery, an electric current composed of free electron will flow in the circuit. If the copper wire is connected in a closed circuit with a battery, an electric current composed of free electrons will flow in that circuit. Definition, we have a definition. Electric current, the definition of electric current. Okay, what's the meaning of electric current? Electric current is the flow of negative charges, okay, which is electrons in a conduction substance or a metal wire, like copper, of course. This is the way we draw the electric circuit. It consists of battery, which is the generation of electricity come from it, the generation of electrons. It's a hub of electrons. So the electron began to transfer from the negative one to the positive one through the circuit, the copper wire, like this. And we also have right here the light bulb. So when we connect the circuit to the battery, the light bulb will begin to illuminate. Okay. We have some physical properties of electric current, like current intensity, potential difference, and electric resistance. Again, current intensity, potential difference, and electric resistance. Okay, let's have a symbol of each one of them. A current intensity has a symbol which is I. A potential difference has an example or a symbol is V, and electric resistance has a symbol which is R. So we have current intensity I, potential difference V, and electric resistance which is R. So these are the symbols we will discuss in our unit, in our lesson. I, V, and R. These are the basic concepts in electricity, in physics. So first of all, we'll discuss the electric current intensity, which has a symbol with which is I. Excellent. Okay, the I. What is the meaning of I, or the electric current intensity? Or the electric current intensity is a quantity of electric charge flowing through a cross section of a conductor in 1 second. Again, a quantity of electric charge flowing through a cross section in a conductor in 1 second. The instrument used to measure it. Of course, I use some instrument. Like if I want to measure the mass, I use the balance, okay, to balance or whatever. If I want to use some tool to measure the length, I use a ruler, graduated ruler, of course. But if I want to measure the electric current intensity, I use some devices are called ammeter. Ammeter, which is represented by the symbol A. Okay, and the unit of I is ampere. The unit of I is ampere. The unit of electric current intensity is ampere. So we have a measuring tool which is ammeter, and the measuring unit is ampere. Mathematical relation. How can I measure the electric current intensity? Which is I? I equal quantity of charged electrons, quantity over time. So I want to measure the quantity that passed in the electric current over a time. So I equal quantity over time. Again, I equal quantity over time. Again, I equal quantity over time, less time. I equal quantity over time. Okay. Definition of ampere. What is the definition of ampere? Ampere has a very important definition. It's the unit of the electric current. So that it is the current intensity when one coulomb, and we will know the meaning of coulomb right now, when one coulomb of charge passes through the cross section of the conductor in 1 second. Okay, let's see the figure. Right now, the definition of ampere, it is the current intensity when one coulomb, just one coulomb of charge passes through the cross section of the conductor in 1 second. Okay, we have here the electric cell, which is 1.5 volt. This is the potential difference of it. And we have something else is called ammeter, and this ammeter calculates the current intensity of the electric current that passes through the wire. Okay, a solved problem. If we have 5,400 coulomb, this means that this is quantity. Let's dive it. This is quantity Q, and this coulomb pass through a conductor of in 5 minutes. Of course, this is time. This is time. Calculate the current intensity. Current intensity, of course, I can't use time in minutes. I use time in seconds. So I convert 5 times 60, so it will be equal 300 seconds. So time, the new time we'll use is 300 seconds. Then now I began to calculate. I know that I equal Q over T. Yes, I equal Q over T. So Q equal 5,400 over T, which is 300. 0, 0, 0, 0, 500, or 54 divided 3 equals whatever it is, so it will be equal 18. Okay, 18. Don't forget the unit of I. The unit of I is ampere. Okay, this is how we can calculate it. Okay, number 2, we'll have the electric potential difference. What is the meaning of electric potential difference? Electric potential difference is the difference between the electric or electricity in the two poles of the cell. Like, it is a state of electric conductor. It is a state of electric conductor which determine what, mister? Determine the transfer of energy, the transfer of electricity to or from the conductor when connected to another conductor. This is the definition of the potential difference, which is symbolized by V. Okay, when two charged conductors touch and they have different potential electric charge flow from the conductor with high electric potential to the conductor with low electric potential. So if this one has a 15 volt and this one has a 30 volt, the electric current will flow from the 15 volt to the 30 volt, like this. So this is the direction of flowing of the electric current. Okay. Okay, this is low, sorry, this is opposite. Okay, whatever. If this is the 15 and this is a 30 volt, this is low electric potential and this is high electric potential, so the electric potential will flow like this. Okay, some useful terms and their definitions. Like joule unit of work. It is work done by a force of 1 Newton to transfer of object at distance equal 1 meter. Potential difference. It is a work done to transfer a quantity of electric charge between the two ends. Again, it is a work done to transfer a quantity of electric charge between the two ends of the conductor, and we can use a law to measure it. So potential difference equal work in joule divided the charge in coulomb. Number 3, volt, unit of difference or potential difference. The volt, it is a potential difference. So the unit of potential difference. So if I want to define it, I began with it is a potential difference between the two poles of a conductor, where 1 joule is done to transfer 1 coulomb. 1 joule is done to transfer 1 coulomb of a charge. Number 4, Coulomb unit of electric charge. Of course, it is the charge transferred by constant current of 1 ampere in 1 second. Number 5, electromotive force, EMF or electromotive force. What's the meaning of EMF or electromotive force? It is electric potential difference between the two poles of the battery. When the electric circuit is open, the unit is volt. Okay. Again, electromotive force, EMF, it is the electric potential difference, one type of it, between the two poles of the battery. When the electric circuit is open, its unit is volt. Okay, measuring potential difference, how we can measure it? The voltmeter is a device that measures the potential difference and electromotive force. Its symbol is V. The voltmeter is connected to the circuit in parallel to prevent the current from passing through the voltmeter. Okay, so the voltmeter is used to measure EMF also, and the voltmeter is used to measure the potential difference across the lamp. So it's used to measure both the EMF and the potential difference, while the ammeter is used to measure the electric current. Exactly. The electric resistance, number 3. The electric resistance, which is symbolized by the letter R, resistance R. Okay, the electric resistance has a definition, of course. The electric resistance is obstruction to the flow of the current in the electric current. It is measured by an instrument called ohmmeter. Okay, the device is ohmmeter. Unlike the potential difference, which is measured by voltmeter, and the electric current, which is measured by ampere. So its unit is ohm. Its unit is ohm. The device is ohmmeter. The unit is ohm. Okay. Definition of ohm: it is a resistance. It is a resistance of the conductor to flow of a current of 1 ampere, where the potential difference is 1 volt. Resistance has two types, constant and variable. Again, constant and variable. In the electric circuit, we have symbols. We don't like to type many things, so we have some symbols. The symbol of the constant resistance is the symbol. Yes, and the symbol of the variable resistance is that symbol. Yeah, that symbol. What is the difference between them? The difference between them is this arrow. This arrow represents the variable resistance, and we will see it in the lab. This is the variable resistance in the lab that we will see, inshallah. Okay? Okay, let's continue. The components of the variable resistance. What is the components of the variable resistance? Okay. We know that variable resistance is a resistance that changes over time. So the component of it, we will have number 1, a metallic wire of high resistance wrapped around a cylinder made of insulating such as porcelain. Okay, so letter A again, a metallic wire of high resistance wrapped around a cylinder made of an insulator such as porcelain. So this black substance is the metallic wire wrapped around a cylinder. This cylinder is made up of an insulating material such as porcelain. Letter B. Letter B here is a copper sheet that can slide over the whole length of the wire, called the slider. This is a slider. A copper sheet. Okay. How the variable resistance works or operates? Changing the length of the wire changes the resistance. Of course, the length of the wire changes the resistance. It's obvious. Number two, increasing the length of the wire increases the resistance and decreases the current intensity. Number three, decreasing the length of the wire decreases the resistance and increase the current intensity, direct and inversely proportional. Okay. We have something called Ohm's law. Ohm's law. Ohm's law, this is a scientist that made a law to measure the resistance itself. So Ohm's law. Ohm's law say that current intensity is directly proportional to the potential difference across the end of the conductor at a constant temperature. So he say that R, which is resistance, if you want to measure it, R equal the potential difference, which is V, over I, which is current intensity. So again, the Ohm's law, this is Ohm's law. It says that the current intensity is directly proportional to the potential difference across the end of the conductor at a constant temperature. So we have some terms like here. We have Ohm. Ohm say that the resistance of a conductor, where the current intensity is 1 ampere and its potential difference is 1 volt. Okay, ampere, it's the current intensity in a conductor whose resistance is 1 ohm and its potential difference is 1 volt. Volt, it is a potential difference between the two poles of a conductor whose resistance is 1 ohm and the current intensity is 1 ampere. So we have here the three definitions. Mathematical representation of the Ohm law. I said that R equal V over I. Yes, exactly. What about this law? I equal V over I is the same one. The mathematics, you can replace them together. Okay. And at the end, we have a solved problem right here. The solved problem say the intensity of a current is 20 ampere passes through a heater where the potential difference is 220 volt, and calculate the heater resistance. We use the triangle whenever you have the value of two variables to find the third. Okay, so R equal V over I. So R equal V, which is 200. Yes, R equal V over I. So V equal 220 over 20 equal, yes, 11 ohm. Okay, this is how we can use laws to solve the problem. Okay, here we end today the lesson number 1 in unit number 2, and goodbye.